Question 6, Part B. A tank initially holds 3,600 litres of water. The water drains from the bottom of the tank. The tank takes 60 minutes to empty. A mathematical model predicts that the volume, V litres of water that will remain in the tank after T minutes, is given by V equals 3,600 times 1 minus T over 60 in brackets to the power of 2, where T is greater than or equal to 0 and less than or equal to 60. Part 1. What volume does the model predict will remain after 10 minutes? Let T equal 10, so V of 10 is equal to 3,600 times open bracket 1 minus 10 over 60 close bracket to the power of 2, which equals 2,500. Therefore, 2,500 litres of water remains after 10 minutes. Part 2. At what rate does the model predict that the water will drain from the tank after 20 minutes? The question is asking for the rate of change of the volume of water in the tank at the 20-minute mark. But in order to do that, we need to find an expression for the rate of change, and that's given by dV dt. So given V is equal to 3,600 times 1 minus T over 60 in brackets to the power of 2, we have a function of a function here, so we need to apply the chain rule to find dV dt. So dV dt is equal to 3,600 times 2 times 1 minus T over 60 in brackets times the derivative of 1 minus T over 60, so that's times negative 1 over 60, which simplifies to negative 120 times 1 minus T over 60 in brackets. Now at time t equals 20, the value of dV dt is equal to negative 120 times 1 minus 20 over 60 in brackets, which equals negative 80. Therefore, water is draining at a rate of 80 litres per minute after 20 minutes. Part 3. At what time does the model predict that the water will drain from the tank at its fastest rate? dV dt represents the rate of change of the volume of water in the tank at time t. Now in part 2, we found an expression for dV dt. dV dt equals negative 120 times 1 minus T over 60 in brackets, where T is greater than or equal to 0 and less than or equal to 60. Expanding the brackets, we get dV dt equals negative 120 plus 2t. Now this is a linear function. It's in the form y equals mx plus c. The gradient is 2 and the y-intercept is negative 120. Graphing negative 120 plus 2t, for t greater than or equal to 0 and less than or equal to 60, we get a straight line graph with a y-intercept of negative 120 and an x-intercept of 60. Interpreting this graph at time t equals 0, the water is draining at a rate of 120 litres per minute, and at time t equals 60, the water is draining at a rate of 0, since at that time, there's no water left in the tank. So by inspection, the absolute value of dV dt is maximum at time t equals 0 and dV dt equals 0 at time t equals 60. Therefore, at time t equals 0, water is draining at the fastest rate of 120 litres per minute.